Okay. I thought that I would talk a little bit more about openings this morning. Um, in particular, let's start with the three loop openings as I have described them before. Opening A, right hand first, and when you turn your hands this way, it touches on the bottom string. If I do right DNA, touches both strings, left DNA, doesn't touch, and opening B touches on the top. There's another way of looking at that. If I do left and then right, I have opening B. If I do right and then left, I have opening A. So instead of saying opening A, opening B, LDNA, and RDNA, you could just as easily say left, 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 right, 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 left. And that would cascade up into a for loop. This would be left, left, left. And you could, of course, have left, right, left, left, right, 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 right. And if you do all the different permutations, you would have 3 times 2 times 1 is 6 different openings. And of course, you could do the for loop, the 5 loop openings, left, 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 and so forth. And that way you could encapsulate all the different openings. The other thing that I've been talking about in my koi fish and my eagle is dominant switches. If I do left, left, and a left dominant switch, I get that little hole in the center. And if I were to finish this with the Inuit net, I would get this in the center. And if you can come in on that, you will see that it is a little more complex than it at first looks. It has a loop here holding those 2 center loops and a loop over here, and it's fairly symmetrical. If I were to do a right, left, and a left dominant switch, I would get a similar looking center. But I think I remember that this particular loop on my right hand here had this string in front of this string so that it would be different in its reality. And of course, if I were to do right, right, and a left dominant switch, I'm going to get a different center. And if I do the fourth, which would be, I forgot which one it would be, but it would be left, perhaps left, no, it's right, right, and a left dominant. I don't remember what it was, but I will detail in my talk about it underneath my video exactly the different kinds of things you can do. You can also left, left, left dominant, and you get a different sort of center in the fact that you will have you can come in here a little bit, you will see that there is a tendency for it to double wrap here in the center. It doesn't, there we go. It's a very different sort of little center that you would have because you did the double left dominant switch. But I'm saying that there is a very complex number of things, a fairly large number of things that you can do in the beginning of any string figure to make a different complex center. And of course, most of my string figures are iterative, and once you have that complex center, the iterations tend to do the same thing each time, and they do not have the opportunity for the particular differences that that first set of weaves will make. Now, let's cascade this up a little bit, and I have to get a longer string here, and I will try to unravel it while I talk about what I'm talking about. And that is, let's, just for the sake of conjecture a 5-loop figure. This 5-loop figure should be left, left, no, excuse me. It will be left, right, left, right, and I will do a left dominant switch and a left dominant switch and a right dominant switch going down from index to ring finger, and then I will encapsulate that particular complexity by using a 5-loop tennis net to hold it so that I can see what that center would do. So what I said was a left, right, left, right, left dominant switch on the index, left dominant switch on the middle, and a right dominant switch on the ring finger. And then I'm going to encapsulate that particular complexity by saying rotate twice thumb away plus twice up through the index. The little finger is up through, this is a little harder for me, up through the ring, and then rotate twice toward. Index goes up through the thumb and back, ring goes up through the little and back, index goes up through the middle, and ring goes up through the middle, and the middle is rotated twice away. There I have my encapsulation. Now I'm going to do a 5-loop ending and see what I have done. There we are. And I will power lift it up and make a little, see if I can turn that around so you can see what I see, because the sides are different. And that's a little face, a little grotesque mask, if you will. Eyes, bent nose, little top knot up top there, and a kind of strange chin down at the bottom. And I have made a couple of pictures of this so that you can see more clearly and have a chance to look it over exactly what it is. And I also have the same idea on a picture with a right, left, and all of the interior moves would be a right dominant switch, a right dominant switch, a left dominant switch, and then encapsulate it, and it would be essentially the chiral image of this particular figure, and I have a picture of that which you can look at also. But the thing that I'm trying to talk about is the fact that this center is plenipotentiary to assume its own shape as you do it. But you'll notice that it's kind of limited, but it is a fairly interesting. I mean, you can make it all kinds of grotesque things, and if I were a a complex molecule over the millennia, I would have had plenty of time to find out which particular complexity in terms of the folding and the spinning and the encapsulation would have a most fortunate geometry after it had finally assumed its folded shape.